let's look back over what we did. We were looking for extrema on an interval, right? So we defined what our extreme values are, our maximums and our minimums, right? We were talking about relative maximums and minimums. Okay, that happens when we have a horizontal asymptote here, right? Excuse me. So, but you use the first derivative, right? We find the first derivative and we find our zeros. That gives us our critical points, right? Make sense? Remember doing that? Okay. So we went through all that. Then we had our first derivative test with our critical numbers. So we found our critical points. We took the derivative. We found the zeros. These are our critical points. Excuse me. Then we figured out when it was positive and negative, so we can figure out when it's increasing and decreasing, and if we had a relative maximum or minimum. Okay, all of that from the derivative, right? Because the derivative tells us a whole lot about f itself. Right? We okay with all that? So those were relative maximums and minimums, not over an interval, even though that's the title of the thing. It's just in general, here's some relative maximums and minimums for our entire function. So now we're going to get to an actual interval. Here we go. With the candidates test. Okay? So we're going to start off here. It says draw a continuous function on a closed interval from A to B with the characteristics for each of the situations below. All right, so I want a max at an endpoint and a minimum at an endpoint. So we're just going to do a little sketch here. So we have A, we have, well, maybe I should wait here just a second. From here to here, here's A and B. So I'm going to have a max at an endpoint. So that can be my maximum. And then that can be my minimum there, where this is A and this is B. Okay? You could have done a linear. That would have totally worked too. Lots of options. Okay? So try and do something for B. Max not at an endpoint and a minimum at an endpoint. Is that cosine? Oh, up there. I was like, what the heck are you talking about? All right, so I want a minimum at an endpoint. Here's this, and then my maximum not at an endpoint, something like that. Would that work? Or the opposite, right? It doesn't have to be exactly like mine, but your minimum is at an endpoint, your maximum is not. This is A, this is B. Okay, so then we want the minimum not at an endpoint, max at an endpoint. What could that look like? So I want a max at an endpoint. Minimum not at an endpoint. Something like that, maybe. Or the opposite again, because it doesn't say which endpoint the max has to be at. But here's my maximum. It's at an endpoint. My minimum is not. As long as that works for yours, then you're good. Everybody okay with that? All right. Max not at an endpoint, minimum not at an endpoint. Does that work? Or something similar to that? It doesn't have to be exactly like mine, but here I have a max that's not at an endpoint and a minimum. No, your minimum is that this is your minimum. That's at an endpoint.
Yeah, I told you.
That makes sense? So your max is not an endpoint, but your minimum is. It's going to have to curve back up. All right. What about max not at an endpoint and not differentiable at the maximum? So it doesn't say anything about your minimum. What's some reasons that a cusp would be a good one? A hole. But if you have a hole, is it going to be a maximum? Because if there's a hole there, there's not a value, so it can't be a maximum. Does that make sense? But that would make it not differentiable. Pointy. Like that. So there you go. The max is not at the endpoint, and it's not differentiable at the max. Something like that. Doesn't have to be exactly like mine. It doesn't say anything about the minimum. I'll give you a little longer on this one. Maximum, minimum, not at an endpoint or at a critical point. Well, that's not when the derivative equals 0, because that's where we get our critical points from. What are your critical points? Maximum is a minimum. So think about what it's asking you. Maximum or minimum can't be at the endpoint, and it can't be at a maximum or minimum. Is basically what it says. So do you think you can draw anything like that? No. Okay? This is not possible. It's just not possible. What we are getting from this is all these different things are happening. If you have a closed interval, meaning we're including the endpoints, then you are going to have a maximum and minimum. It's either going to happen at an endpoint or it's going to happen at a critical point. Those are your only options. Okay? Does that make sense to you? So it has to be at a critical point or one of the endpoints. And it's only when you have a closed interval, not just on a function with no interval on it. Okay, this is called the extreme value theorem. So we had the intermediate value theorem, the mean value theorem, and now we have the extreme value theorem. So IVT, MVT, EVT. So EVT, extreme value theorem, says every continuous function on a closed interval has an absolute max and an absolute min. Oops. On that closed interval. I didn't mean to mark it out. Okay, it has to be continuous, because if it's not continuous, then it just doesn't work. It has to be a closed interval because you can't have arrows, because that goes to infinity. Infinity is not a value. So it says for a continuous function on a closed interval, the absolute max min must occur at an endpoint or a critical point. The absolute max occurs at either an endpoint or a relative max. We know how to find the relative max, right? And absolute min must occur at either the endpoint or a relative min. We know how to find the relative max and mins. That's what we were doing with on the other pages of these notes. Okay? So here's how we find it, and this is called the candidates test, which we will use in future endeavors. So to find the extrema for a continuous function on a closed interval, use the following steps. We find the derivative and the critical numbers, right? So in order to find your critical points, you find the derivative, find the zeros at those points, right? And then we set both the numerator and denominator equal to that. We evaluate the function at each critical number and each endpoint. Excuse me. Each critical number and each endpoint. The least of these values is the minimum, the greatest is the maximum. Okay, so let's check this out here. So the first thing it tells us to do is to find the derivative. So let's find f prime of x. That's equal to 6x minus 12x squared. So then, I have this, I need the zeros. So this, I can factor out the 6x. That leaves me with 1 minus 2x. Now that it's factored, I set 6x equal to 0. and I set 1 minus 2x equal to 0. So I get x equals 0, 1 equals 2x, so x equals 1/2. Okay. Everybody okay with that? All right, so I need to find on this interval the absolute maximum, absolute minimum. So how do you think I could find the maximum? Because can I test every single point from -1 to 2? I can use -1 and 2, and then these two, right? How many points exist between -1 and 2? An infinite amount, yeah. There's 2 critical points in between there. You were answering a different question. You weren't wrong, just a different question. There are 2 critical points, but there's an infinite amount of points, right? But we already know that these are critical points from what we did before. This is a relative maximum or minimum on the entire function, but it could be an absolute maximum or minimum based on this interval right here. Okay, y'all with me on that? So we're going to make a little t-chart here. And on this, we use the endpoints and any critical points we found. So I start with -1, then I have 0, then 1/2, and then 2. Okay, those are the x values I have. The 2 endpoints and my 2 critical points, and I'm just putting them in order from least to greatest. I need to evaluate these. Well, I put x and y. This is really f of x. So not f prime of x, but f of x. So that means I need to find f of -1, not f prime of -1, f of -1. Okay, you're substituting them back into here. So -1 squared is 1, so I get 3 minus, well, -1 cubed is -1 times 4, so this will be +4, and then +1. When I add all that up, I get 8. What is f of 0? 1. Okay, so we don't have to really do much there. Then I need f of 1/2. Oh, please. What's 1/2 squared? 1/4 times 3 is 3/4. Yikes. 1/2 cubed is 1/8. So it'd be 4/8, which is 1/2. So minus 1/2 plus 1. What's 3/4 minus 1/2? 1/4, right? It's like 75 cents minus 50 cents. Yes, so it's 5/4. And then to f of 2, that's going to be 12 minus, well, 2 cubed is 8 times 4 is 32 plus 1. What do we get? -19. Okay, so let's think about what we have. We have 4 points that we know are on this closed interval. So I could, if we wanted to graph these, I just want to do this on this first one. I have a point at -1, one at 0, one at 1/2, and one at 2. Okay, this is not going to be very to scale at all. So at -1, I'm at 8. That looks good right there. At 0, I'm at 1. At 1/2, I'm at 5/4, which is a little bit more than 1. And at 2, I'm at -19, way down here. So I found 4 ordered pairs. One of them is the maximum, one of them is the minimum. What is the maximum value? 8. Where is that? At -1. So we can say the max is 8 at x equals -1. No, you can just say that it's 8. It's fine. And then minimum is what? Negative 19 at x equals 2. That's your candidates test. You check the endpoints, you check the critical points. Okay. We good? What questions you got? All right, let's try this next one. All right, so I'm going to take the derivative first. G prime of x. I'm going to multiply 2/3 times 3. What's 2/3 times 3? 2. So I get 2x to the what? Negative 1/3, because it's 2/3 minus 1, right? Minus 2. So that means that this is the same thing as 2 over x to the 1/3 power minus 2. So I need to get this all into one term, like one fraction basically. So g prime of x equals, what would my common denominator be? X to the 1/3. And then that first, so 2 is the numerator here, minus 2 times x to the 1/3 power. When I get my common denominator. All right, are we all good so far? So let's think about what happens with the rational. So g prime of x equals 0 when 2 minus 2x times x to the 1/3 power equals 0. You just take the numerators when it equals 0, right? So then to solve this is going to give me 2 equals 2 times x to the 1/3 power. Divide by 2, I get 1 equals x to the 1/3 power. So what does x equal? 1. Then g prime of x does not exist when? When x to the 1/3 equals 0, so that means x equals 0. So those are my critical points. I have a critical point on this function at 0 and at 1. Everybody okay with all that so far? So now I put them on my little chart for my candidates test. I have x and g of x. So start with the smallest one, that'll be negative 8. Then my two critical points are 0 and 1. My other endpoint is 1. So my endpoint and one of the critical points is the same thing. That's totally fine. Everybody with me? So now I need to substitute these back into the original. So g of negative 8. So negative 8 to the 2/3 power is like taking the cube root and then squaring it. So the cube root of negative 8 is negative 2. I squared, I get 4. So then 3 times 4 is 12. Then plus 16 plus 1. What do we get? 29. Okay. What is g of 0? 1. Then I need g of 1. G of 1 is 3 minus 2 plus 1, which is 2. Okay, so based on that, for my candidates test, I can say that max is 29 at x equals negative 8. The minimum is what? 1 at x equals 0. What questions do you have? You don't have to do the little graph every time. I just did it that first time so you could see what was happening there. Are we good? Any questions? Okay. All right. Now we have h of x. I want you to find this derivative. Find this derivative, h prime of x. Is it going to help to rewrite that sine squared of x? Do you remember doing that? Yes, it absolutely will. Rewrite this as sine of x squared. Do the chain rule.
You lied to me.
Why are y'all listening to him? You can just find the derivative. We'll do the rest together. Okay, so if I'm going to have to use the chain rule here, I would always rewrite this. I rewrite it 2 instead of just thinking. So I don't mess things up. So 2 comes out in front. So I get 2 times the sine of x, and that would become to the first power. Then I have to take the derivative of what's on the inside, so that's cosine of x. Then plus cosine of x, well, the derivative of cosine is negative sine x. This is what your derivative looks like. We good? We can't forget how to take derivatives. Okay, so now I need to find my critical points. I do that by finding the zeros of the derivative. So I set this equal to 0. 0 equals, and I can factor out a GCF here. My GCF is the sine of x. That leaves me with 2 cosine of x minus 1. We agree with that? Okay. So then 0 product rule. I'm going to do the sine of x equals 0 and 2 cosine of x minus 1 equals 0. All right, so my interval is from 0 to 2 pi. When do you get a sine value of 0? Okay, so 0, pi, and 2 pi. All right, that's when sine is 0. So then I get, that's right. So then I get 2 cosine of x equals 1. So, ooh. I get cosine of x equals 1/2. So using your hand trick, pi thirds. Okay, so.
Oh, pi thirds and 5 pi thirds?
And 5 pi thirds, very good. Because cosine is positive in the first and fourth quadrants. All right, everybody good so far? Okay, so we have found our critical points. We know our endpoints. We are going to put them, this is x and h of x. So this is 0. What comes next? Because these are what I'm using here. Comes next in the order. Pi thirds, pi, 5 pi thirds, and then 2 pi. I just had to order them. So once again, my endpoints were also my critical values, which is totally fine. Okay. Then I need to find h of x. So remember, you don't put it in h prime, we can put it back in h of x. So what's the sine of 0? Sine of 0 is 0. You square it, you still get 0. What's the cosine of 0? 1. So this is 1. What is the sine of pi thirds? Square root of 3. Square root of 3 over 2. But then I have to square it. So that gives me 3 over 4. Sine squared. Okay, so look, let's write this out. We have h of pi thirds. The sine of pi thirds is the square root of 3 over 2. And then we have to square it. Plus, what's the cosine of pi thirds? 1/2. Square root of 3 over 2 squared is? It's what? It's 3/4 plus 1/2. Okay. I was like, what? Now it's 5/4. Okay. Just making sure we were all 5/4. We all good with that? Understand how we got it? Okay. Then we do pi. The sine of pi is 0. I squared it 0. Cosine of pi is? It's -1. All right, 5 pi thirds. The sine of 5 pi thirds is negative square root of 3 over 2. But when we square it, it becomes positive, it becomes 3/4 again, plus 1/2. We end up with the same thing, the 5/4. And then 2 pi is going to give me 0 for this and 1 for this. Are we all good with those? Okay. So what is our max value? 5/4. So our max value, because remember that's always the y value, max value is 5/4 at x equals pi thirds and what? 5 pi thirds. So you only have one maximum value, but it can occur at multiple spots. Does that make sense to you? All right, so then we can say the minimum value is what? -1 at x equals pi. What questions do you have? We all good? Okay, well, we're going to pause here right now.